Okay, hello. So I'm going to show you something I've been working on. It's a rather huge change to Cerebral, but we have to iterate and move on and take advantage of the latest and best solutions out there. So initially I tried to work on proxies to improve typing support for Cerebral. But I hit a brick wall there related to like composing proxies together. It just won't work. So, but it led me to think about Mobx and how Mobx really is about observables. Like Mobx is like branded as a state management tool, but if you remember, it was initially published as like Mobservable. So Mobx is really about just values and how to observe them. And then Mobx is kind of a state management tool where you have like actions and stuff. But at the core, it's about observing values. So I actually just spent one evening refactoring Cerebral to use Mobx instead. And I had a running demo, but I've been changing the code so much, so I can't run it. But it actually works. So what I thought I would do here instead is go through how you would be able to build a Cerebral app using TypeScript. And I'm going to talk about how things will change if we do this change to the project, or maybe we need to fork it into a different project because there are so many changes. But anyways, let me show you what I have this far. Okay, so in the root folder, this is to do MVC. We have a types file. So this is like the main types, and those are related to like what's the total state of the application, what are all the signals, and all that stuff. So what we see here is I'm importing the module state and the module signals, and also a provider from the root module called app. And then just to show you how you compose it together with other modules, I'm importing module state from a different module. So the way this works is that I export a state type which has the root app module state, and then we bring in also this module state. So if you had a submodule of module A, you would do the same here. Submodule A, and that will be imported as well. So you kind of like rebuild the nested structure in this type here. And it will be the same for signals. And then we have a type called connect. And connect is what you use when you connect to the components. And what you can connect to the components is the state, the signals, and optionally you have props. So I'll show you how that works. And then we have context, and this is used in actions. And actions also has state and optionally props. You might have path there, and you also have this provider available called ID provider in this example. Okay, so how does this actually look? Thought maybe we could look at the components first. So if we have a look inside app, we can see that we have like normal code here, but the connect is a function instead of just an object. And the reason is that this function takes in the state and the signals and the props if defined. So as you can see here, we have counts, which we can see the type and everything. And the really important thing, the reason it looks like this is because everything is inferred, which means that, okay, we just add this connect, but then we have access to all the state of the application. And we also have the signals. So if we have signals here, blah, signals dot clear completed. Clicked. Oh, sorry, it's the TV. Yeah, and you even see Yeah, okay, this one doesn't have. Let's look at a different one. Filter clicked, and you can even see like it takes a filter, and that's a string. So you see everything here. Cool. And then when you look at the actual components, we can see that, okay, we have the correct type, and we see, yeah, it's a number, and everything's inferred here, which is pretty awesome. Because as I've seen examples of, you have to do a lot of wiring here to make the component understand what it can access. But this just works. Cool. Maybe we can move into, yeah, like footer. It's the same thing. We connect, we have connect here, and we have like the filter, we have the counts again. Here we have a signal, and everything, yeah, looks like it's supposed to. So this is really nice. One thing to talk about here is that in Mobx, you don't do this kind of connect. You just inject the whole state store, but we don't do that. And I think that's a huge benefit. And the reason is that this is the part that is actually observed. Like we don't observe anything related to the component. We just observe the state dependencies. Which is really nice because I just made a tiny change to the view of Cerebral, and that is being used by every view connector. So like this will work for Vue and Angular and everything else because we explicitly state what state we want access to. So that's one huge benefit. The second huge benefit is that the component just depends on props. It doesn't depend on an injected store. So it's a lot easier to test the component, and also if you want to make the component more flexible. Let's say in one situation you actually want to connect it to the Cerebral state store, but in a different scenario you just want to pass the props manually, you can do that. So yeah, I think this makes a ton of sense. Cool. So let's move into the actual module here. Maybe we can look at index first. So when you define a module, the way it works now is that you pass it the module state and the module signals. That way you can define the state and the signals directly in the module definition, but if you do something wrong, it starts to yell at you. So here we have the state. We also see this Cerebral map here. Now the thing is with Mobx, when you have dynamic objects, like where you don't predefine the keys of the object, you have to use a map. And we could like use observable map directly here, but I kind of want to hide, at least in the API, I want to hide the fact that it's being run by Mobx, because Mobx is very low level. But of course, like in the documentation, when we talk about Cerebral, of course, talking about Mobx will be really important. But yeah, not on the API level. And people shouldn't like think about observables and all this stuff in the beginning. That's like a low-level implementation. Anyways, so we use a Cerebral map wherever we have an object where we remove and add keys. In this case, it's the to-dos. Nothing special about filter and editing UID, but then we have something called getters. So Cerebral has this computed concept, but it's not that great in terms of optimizations and how you define them. But with Mobx, you have a concept of a getter. The syntax is a little bit off, so what I decided to do is create a factory for it. So a getter has access to the state, and it can then, we'll look at an example, but it has access to the state and it returns a value based on different state. And it will update if any of the state dependencies update. You don't think about this in Mobx. You just grab the state and it will be optimized for updating. There's also a concept of a computed. The difference between a getter and a computed is is that a getter is just a property. So like you say state.visible to-dos UIDs, and you get the state. But the computed will be state hello, and you would actually call it like a function. Hello. And then you would have some state dependencies using this argument. But the cool thing is that Mobx computed actually caches the result based on the argument and stuff like that. So you would do the same thing there. Just use computed instead of getter. Okay, but let's have a look at, for example, counts here. Getters. So the way this looks is that you give it, it receives the state. And in this case, I'm saying module state, but it would actually include any nested modules and stuff. But yeah, ignore that for now. So here you have access to state as normal, everything as normal. The reason it gives a warning here is because when we go and grab to do, it might not be there. So there should really be a check for the existence of this to do first, but I haven't refactored that. But anyways, the good thing is that with these maps, so to-dos, you actually you see that it's a map. So you don't accidentally point wrong to this this value. Anyways, so we just go and grab the state we need, and we do whatever we need and return it. And it just works. You don't have to think about it, which is amazingly nice to have. Okay, so that's new. And then we have, and of course you can use this in actions as well. It doesn't matter. It just works. And then we have signals. And now there's a factory for a signal, and the reason is that when we define a signal, it's like a sequence, but when we use it, it's a function. So to make the typing work correctly here, we have to use a factory. But the nice thing is, like, you can just hover it and it tells you how you call it. Like, this requires a filter, which is a string, and all that stuff. Nothing more special than that. Cool. So let's have a quick look at the types. It's what you would expect. Like, we created to do, we have counts here, and then we have the actual module state, where we have a map of to-dos, string, blah blah. Nothing special about this. I also want to mention Mobx state tree, because there is an add-on now for Mobx state tree, but I think it's totally overkill, because Cerebral already has the state structure using modules, and Mobx state tree has its own runtime typing system, which to me that seems really, really weird, because we have TypeScript and Flow and that stuff. So if you want to do typing, you should rather use that instead of like a runtime typing system. So yeah, so there's like nothing Mobx state tree about this. It's just the Mobx observables being used to define the state and react to changes on it. By the way, we have the protection and everything here, so when you can only change state in actions and stuff like that, and it does transactions, so it batches up. If multiple actions run synchronously and does state changes, it batches it up and stuff like that. It's really good. Okay, anyways, so let's have a look at sequences. Nothing special about this. You just define it as a signal chain. I will probably change this to like sequence instead, but yeah. And then we have the actions. As you see, there's no operators here. And the reason is that it doesn't make any sense, because it's so easy to define just using an action. So for example, here we wanted to change the new to-do title. We could inline state like this, state, yeah, and I haven't added the context type here, but anyways, new to-do title props, oops, sorry, equals props title or something. So if you want to inline it like this, it's super simple. But operators also has a cost in terms of declarativeness. Like a single operator is very declarative, but when you get tons of them, the sequence becomes less declarative. But with this approach, you always just reference functions. So it's as declarative as it can be. Anyways, let's have a look at the actions. So the way you define an action is that you bring in the context. And on the context, you can optionally set what you expect on the props. And then again, you have access to the full state tree. And the props are not inferred by the execution of the signal. It's just inferred by what you define up here. Like this is the super dynamic part of Cerebral, is the signal execution and how these actions are used in the sequence and what props are passed and stuff. It's impossible to statically analyze it. Just for one simple reason, is that you can use one action in multiple sequences, which has different props and different paths. So it's impossible to statically analyze that. But the reason you actually add this, like it might not make sense, but the reason you add it is because if you make a change to a new to-do title and you assign props.title to this state value, and you have said that props.title is a string, but suddenly new to-do title is a number, then this action will throw an error. So it's just for maintainability. Okay, and again, if you have path, you can pass in, like here we pass in the props, and then we can pass in the path instead, or in addition to the props, if you want to do that. Cool, and then this is throwing an error because it might not be a to-do there. Cool, but there's nothing special happening here. We're just changing state directly. There's no string API, nothing like that. And we get full auto-suggestion support. And it's really, really nice. Okay, cool. I think that's what I wanted to show. And yeah, you just have to believe me that this actually runs. What's missing now is actually implementing some of the new stuff I mentioned here, like related to, like here for example, like Cerebral map doesn't really exist, getter doesn't exist, signal doesn't exist, but I have experimented with it, so I know it will work. But yeah, I actually need to implement it. Cool. But yeah, I guess that's it. So I hope this made sense, and I'll keep working on this. Like what we'll do with this, if it's going to be Cerebral 5. As you can see, it's quite a bit of changes. So maybe it should be branded as a new project. I don't know. We will have to discuss that, but yeah, give me some feedback if you like it or have some suggestions or questions, and I'll talk to you later. Bye bye.